Hello Lakshmikant, good morning. Alright, let me just check few more things. So we are about to start our discussion on Hive. So do you have any questions about what we have discussed yet till yesterday? So till yesterday what we talked about is first Hive is used for querying the data which is lying in HDFS or HBase or which is lying in the I mean the any other database which is on the big data. Okay, so essentially we write our queries in SQL and Hive converts it into MapReduce under the hood. All right. So the we also discussed the benefits over of Hive over Pig or MapReduce. We also discussed when to use Pig instead of Hive. And so, alright, so in case of, so can you explain replicated in pig? Alright, alright, so yeah, yes, we can do that. Alright, so, alright. Now, when we were discussing about join, if you remember correctly, so when we were discussing about map reduce joins, so lots of people said that why don't when joining the two data, so I think it would be better if I open the okay. So let's just say yeah. All right. So here we have. So the objective here is to join two tables, correct? One table containing name and the country name, and all you want to do is convert the country name into country code, correct? Now there are two ways to do it. One is we join these two tables, and the usual join means that these two tables will be basically concatenated. I mean, from first table, the key values is going to be the country is going to be the key, and in the second one also the country is going to be the key, and we concatenate, let Hadoop sort it so that the code and the name of the people come together so that we can we can easily infer the name, the country code with respect to a country name. Correct? So if you remember our joining example in MapReduce, right? So general way is this. If we do the MapReduce, the standard MapReduce for joining, so we basically on whatever field we are trying to join, on whatever field we are trying to join two tables, we create the key value pair such that key is the column on which we are joining the table and value is the whole row. And then when we join these tables together, the the rows on which the keys is same, they come together, and that's how we join the records. Correct? Now in this if you notice that the data is small. So the second table is fairly small, right? So using a standard join is too much of an overkill. And the first approach which everybody suggested while joining, that load everything from the second table into memory, go through first table record by record, looking up in the memory and replacing the country name with the code. Okay? So that's how it is done generally. Okay. So are you with me on this? No. So one way is to join these two tables just like we did in MapReduce. Other way is loading the second table into the memory and then going through these 1 billion entries one record at a time, looking up for country name in this second table which is we have loaded into memory, and then replacing it. Okay. And what does it mean by rotating loading into memory is that we'll have all the nodes which are doing maps, and all these maps will get a copy of the second table so that they can quickly look it up into the memory, and then they will be able to replace country name with the code. All right. So this way you can basically, when the second table is small, if were using MapReduce, we could have used this clever technique, but we were using pig. Therefore, pig had to provide us with a keyword called replicated, so that we can mark a table as replicated for joining. Okay, that means second table will be loaded into the memory, and while first one will not be loaded into memory, and maps will be run against the first table. Okay, so if the first table is really huge, and there'll be multiple maps running on first table, and each map will receive a copy of the second table, and load each mapper node will load this second table into memory and will go record by record in the first table, replacing the corresponding country code. All right. I hope that is clear to everyone. So as a thumb rule, whenever you are joining two tables and one of the tables is very small, so small that you are comfortable to load that in memory, then you should go ahead with making the the table which is smaller as replicated. Alright, that's a thumb rule. Alright. So any other questions before we move forward with our HBase? Sorry, Hive. Can we use input format in pig? Yes. So the pig loaders, similar to pig loader, there are multiple other kind of loaders. We can use those. Those internally use input format. All right? Those internally use input format. Correct. You can write custom input format. That's what we called there also serializer, deserializer. Here also there will be serializer, deserializer. We will call them SERDE. So if your data is say in JSON, so there are if your data is JSON or XML, there are XML loaders and JSON loaders, and there are the general kind of loaders which you can use. All right. Okay. So is Hive considered as NoSQL database? No. Hive is not a database. Hive does not store data. Hive basically lets you query the data. While the data is stored either by HDFS or the data is stored by HBase, Hive just lets you query the data. Okay. So Hive in a very informal sense, we can say that Hive is somebody who is letting us write SQL queries instead of coding hundreds of lines. Yeah. All right. Any other questions? So Hive is basically it takes you SQL query from you and then converts it into MapReduce and gets you the results. All right. So you don't have to code too much. Also, your knowledge of SQL is going to be used here. Okay. The only thing is with Hive, you are limited to what SQL can do. And therefore, sometimes when the things which cannot be really done well using SQL, you might have to write MapReduce. But that's rare, and we can basically do it uh, in conjunction with MapReduce. Okay. So in a larger project, some part of it is going to be in Hive, some part might be in MapReduce, or some part might be in Pig. All right. So last time when we started with discussions of managed table. Managed tables are the first kind of tables, basically. So whenever we start in Hive, so in case of a pig, we did not have to define tables, but in case of SQL or Hive, we have to define tables before we start anything. Correct? So here we have before we start loading the data, we have to tell that this is my table and this is where it is going to be stored in HDFS. So as you can see that Hive does not have its own storage, therefore we have to tell that this is where physically it is stored. So so it's saying that if you go through this declaration, it says that create table, the table name, then there is a whole list of columns of various types, starting with exchange, symbol, YMD, open price, high, low, close, volume, and okay. So all of these up to the bracket are the columns, and it basically says that we are trying to create a table with these columns, and the data will be stored at the location given below, which is slash data slash nysc underscore daily. And while representing the table on top of this data, which is at this location, the row format is the fields are delimited by slash t, and by default, instead of slash t, if you don't mention it, I will think that the data is stored separated by control A character. There is a special character called control A, and using that it will be separated. But here we are explicitly saying our data is stored as separated by tab. All right, and once we have defined this kind of a table, if the data already exists at this location, then we will be able to query the data. Okay, we can easily say, if we have this kind of a table, we can say select star from NYSE daily, daily 1, and we will get the results. All right, if we have already if we already have that data at that location, then we do not have to load any more data. All right, so essentially what Hive is doing, there is some file lying on HDFS. It's creating sort of a tabular representation of that. The moment you query it, it will load the data from there. Okay, it will basically get the data from there. That's all. So let's try to run it. Correct, correct. So basically, Kalyan's question is, does it follow the same procedure while storing HDFS, that 128 MB block? Yes, it does. So Hive is essentially, if you look at it, is going to utilize HDFS the way we are. It's going to store its data there, and hence HDFS will take care of replication and data node, name node, and then all of that. All right. So now let's create a table called NYSE daily. So first of all, before we start doing anything, we can see. Okay, so we have created the table, and we can say select star from NYSE daily 1. Okay, not from, it's from. So there is no data right now. All right, and also let's have a look at this physical location here. So you can go into the browser and say So you can see here, and we'll go to slash data and okay, slash data. So here you can see NYSE daily. There is no data right now. Okay. So basically, whenever we are going to select anything from that file, whenever we are going to select anything from that file, it is going to get the data from that location. Okay. All right. Okay. So let's go ahead. Now, next step is let's load some data into this. What kind of file will HDFS create for the table we are creating? So, okay, so let me understand from you, what are the different kinds of files in HDFS? Oh, so basically the files could be in any format which Hive can understand, but right now it's going to have the files which are tab separated. Okay, it's not going to create any file, by the way. It's basically copy the data there. I'll show you. So whatever data we are going to load, it is going to copy this file from this location into the folder location which we have shown you in the browser. So whatever data we load, it is going to copy that file here. Okay. So let's say we are saying load data local in path in this location and overwrite into table called this one. Okay. So if we have this, we can say easily. Okay. So the data is loaded into that location, and here this was my local file. So the syntax is we say load data local, meaning load my data which is locally in the Hadoop one, not in the HDFS, in this path, in this particular path, and then overwrite into, if there is already some data in this table, then overwrite. But in this case we were using NYSE daily, so we'll have to use NYSE daily one. All right. Is the voice breaking for everyone? Okay. Now we can refresh it. Now you can see that the data, whatever we loaded, our file was where we were trying to basically load. Let me open one more session. I am SSHing into Hadoop one. Okay, and there we have we are copying this file from local folder of asgiri slash hive. So this file NYSE daily is what we have loaded into hive from local. Alright, and now that same file has been located here. So this is the data, this is tab separated data. Now we can start querying. Okay, so this is the actual file over which we are given a window which over which we have created the table. So whenever we are querying the table, it's basically going to read this file. Alright, every time we are going to query the table, join the table, or say group by, whatever, this is the file that is going to be the input. All right. Now So if you just copy from local and not specify table, will I be not able to read that file, or else what's the significance of the table? So if you specify just copy from local, okay, so you mean to say, so you are saying, let's say we delete this, correct? Let's say they delete this. First, let me show you that. Okay, so now we are select star from from NYSE daily one, okay, where let me just say where my, okay, so just wait for a minute. So let me just show you. So CLI, let's say we are looking only for CLI, okay, or we are looking for this particular value greater than 30.34.1, okay. So now we are able to query the data from this. Okay. So all we need to write is select star from NYSE daily, where the last value, which is price ADJ close, is greater than 34.1. Okay. We are going to say select star from NYSE daily one, where price adjustment, price ADJ underscore close is greater than 34.1. Okay. Now, if you notice this, we are essentially querying the file which we have just created, and we are using MapReduce under the hood. Okay. So NYSE daily 1 is located as a physical file, and we are querying that file using MapReduce. Okay. And all of this just by simple query. We don't have to know nitty-gritties of MapReduce to execute this. So you can see all the records whose values are greater than 34.1 are listed here. Okay. We can even say and and we can also say things like and price close less than 35. So to do this kind of thing, you will have to write a lot of code in MapReduce. Here it's basically giving you complete control. Also, you are stating the problem, rather than here you are basically stating that this is what we are looking for, instead of telling what exactly Hadoop needs to do. Okay, so you can see this. So from 34.1 to 35 we were able to query. Alright, now let me take your questions. Okay, so these are nice questions. Let me just copy all of these onto so that I can easily express them. Okay. So, alright. So Manishi's question is, so if you just copy from local and not specify table, will Hive not be able to read that file? Definitely it is going to read. I'll show you this. So let's for a time being we delete this data. Okay, we are going to delete this file, or we can also say select here and delete. Alright, we are going to delete it from HDFS. Now see what happens. Okay, now we go back into query and execute the same MapReduce task. The result will be nothing. Okay. If we had not put where condition, it would not have created the MapReduce. All right. If we just say select star from this table, it will not create any MapReduce because it has these optimizations in place. Okay. Now you can see that it has not resulted any of the data. Parallelly, let's go into another terminal. Our local file was where? In this folder, and the name is nysc daily. This is local file. Okay. Now let's copy it. We say Hadoop fs copy from local, okay, into slash data slash nysc daily slash data slash nysc underscore daily. So don't confuse it, because here the name of the folder is same as the name of the file. So we are going to create nysc daily file inside this nysc daily folder. Okay, we have to put dash. Okay, so we have just copied the data from local to there. Now, since we have said specifically here in this that our fields are terminated by tab, meaning our fields are separated by tab. So our file is copied into this folder. Okay. Now we can continue to call our start our SQL work. You can see, you can say limit 10. Alright. For things like limit 10, it does not start any MapReduce process. So is everybody comfortable with this? Alright, so Manish, does that answer your question? Correct. So Basfaraj, this is what you want to do? Run the same query again. What is the format of local file? Yeah, let's have a look at the local file format before so we went here, we say tail this. Okay. So how do you find the format? You can simply try to edit it. Okay. So I'm editing in an editor. So it's basically you can see that it's a plain text file. These are records are separated by new line, one record in each line basically, one record in each line, and inside each record the value the fields are separated by tab. You can see that. Okay. So that answers Lakshmikant your question, I hope. So all right. Now, Basra's question is, if the file is already present in DFS, can we directly run a query on that location? Correct. We can run on that query on that location. Okay. Input data should be separated. Yes, we have already discussed this part. If it is not tab separated, then we'll have to mention whatever separator is there. Okay. If it is in a format which is not a field separated, say for example a complex format like JSON, then we will have to tell Hive how to read the data. Alright. Here we'll have to mention that we'll have to mention something called serializer, deserializer, just like we'll have to mention serializer, deserializer, just like pig loader, and then we'll be able to tell exactly how to read the data using, and inside we'll basically supply that this is your serializer, meaning reading, this is how you are going to read the data, and deserializer, this is how you are going to sorry, serializer as in how, this is how you are going to save the data, deserializer as in how you are going to read the data. Is it possible to alter table structure? Yes. So it provides you the complete DDL, data definition language, alter table and everything. Alright, let me go back to my. So, Basraj, your question is, I hope, answered. And okay, alright. So, Surya, your question is also answered. So, there is no binary data in, we have not stored any binary data. Okay, and the only binary data you would have is this information about table. What are the columns, how they're stored, so that next time when you are logging in, the table should be there. Table definition should be there somewhere so that you can quickly query. All right, and that data is stored in Hive store called Metastore, not Hive store, Metastore, and that's basically an RDBMS like MySQL. All right. I think I got it because you created the table first and then override the data rather than an existing file and creating the table on it. Okay. Alright, now let me again go through the questions. So in case there is no where clause, so in case of select where there is no where clause, no mapper is created in Hive, while in pig mapper will be created. So pig also does little bit of optimization. Okay. So when we said select star from table, all it did was it basically started reading the data directly without any map reduce. So those are the minor optimizations built into Hive so that we get the results really fast. Instead of talking to MapReduce, it will directly talk to HDFS and give you the results. In case of there is no need of creating map and reduce, meaning there is no conditional checks, there is no grouping, and say select star from a table, then it will basically go to HDFS, read the data, give you the data, and that's all. Similarly, if you say select star from my table and you say that limit 10, it will basically only re it will directly read the data from the HDFS and give you only the 10 records. Also, if you have a code which does not require reducer phase, it will not create reducer phase. Okay, so yeah, so your understanding is right. In case of pig also try to do a lot of optimization, and I think pig also does similar kind of steps. Okay. So when we run the table query, what does Hadoop do internally, which lets us use the file as a table? Okay. So when we run the create table query, what does Hadoop do internally, which lets us use the file as a table? So it doesn't do anything. Okay. It works like this. When we create a table, it's not doing anything much. It's basically creating this entry in Hive Metastore, okay, so that this table creation is persisted. Next time you log in, the table should be there. And when we are running the query, at that time it's going and checking the file and trying to basically separate the file based on tab. It basically, while loading the file, it's going to break down the file by new line, and each record it is going to break down by tab. And while we are running the MapReduce, this process is running at that point of time. And when we have these fields separated, then it will cast or convert these values from string to various data types. If we have a field which is float, then that column will become a float. Alright? And when we query that, it will be straightforward. Alright? Alright, so without creating a table, we are able to load the data and retrieve using select as long as data is separated. Correct. Yeah. So now Kalyan's question is that without creating a table, we are able to load the data and retrieve using select as long as data is separated. Then why should we create a table? I did not get, but we had to create a table, right? In SQL, that is the syntax. So when we said select star from a table or run any query, the SQL engine, our Hive engine has to basically run that query, right? To run that query, it might have to know what are the fields in our input table, what are the definition of each field, what is the data type of each field, correct? And okay, so that is the reason. So partly you can say that yes, one big reason is the data type. Because in case of pig, we did not have to define things for querying, right? We could basically, with partial information, we were able to do it. But because SQL demands that all the fields should be well defined, therefore we have defined a table. All right. Good, good. Great set of questions. Keep going. And all right. So this is what we call a managed table. Okay. So although there is not much of a difference between managed or in managed and external table, the only difference is when you drop a managed table, the data gets deleted. This data will get deleted. So if you drop this table which we just created, okay, the data will get deleted. Let's say drop this table. So we say drop table. So now since we have deleted this table, this file will disappear. Okay. So it says the table is not found. All right. The full folder which contained our table has disappeared. Okay. So every table is stored as a folder. There are multiple files for each table. Alright, so we were able to successfully load the data. Here we loaded the data from our local folder. We said local in path. If we remove the local from here, then this load command will try to find the data in our HDFS rather than local file. So we can try to do that. Okay. So also if the file is the file which you are trying to load into our table, if it is located in HDFS, then the file is moved instead of getting copied. Alright? So file is moved instead of getting copied. So let's say that here we are what we are trying to do. We are copying the file from this folder to sgiri. Okay. So we are basically doing this. Not here. We have to. Okay. Now, if we basically so we have uploaded from local file to sgiri folder. Now we can see that it is there. Now the moment we load the data from this file into our table, this is going to be our table, okay, then it is going to give an error. Not error, it is going to basically, okay, so we are loading from our file into our table. So okay, we have already deleted the table. Let's just create the table again. Alright, now once we have created the table, we can go ahead with. So what are we trying to do here is we are trying to load the data. In the previous step, we loaded the data from our local file. Now we are trying to load the data from our HDFS file. Alright, so here we go. So data, instead of getting copied, has been moved. Okay, which means the data is gone from this location. So you can see that the data has been moved from this location. Alright, so this is one thing which you have to keep in mind. Whenever you are loading the data from HDFS, the data gets moved rather than getting copied. Okay, so you can say select star from NYSE daily yeah, you can see that. Alright, if you do not define any separator, it considers it at control A. It will create a directory in the partition. If any, it will create a directory and then copy the data. If the target table is not partitioned, then you omit the partition. We'll talk about partition in a minute. Correct. So partially yes, because if you copy the data rather than moving, if I copy the data rather than moving in HDFS, then then basically there will be 6 copies of the same file, right? Because each file has got 3 copies because of replication factor. And if we are just copying something from duplicating data in HDFS, it's actually unnecessary. That's the reason it moves rather than copying. Okay, it's like when you are on Windows, if you try to drag and drop a folder from same drive to same drive, it moves. While if you try to drag and drop from one drive to another, it copies. Correct? Is the same way. If you try to load the data from local folder to HDFS, then it copies the data. If you try to load the HDFS file into an existing table, into a table, then it moves the data rather than copying. Alright? Similar to like Windows, when you drag one folder into another folder, if the destination is on a different drive, then it copies the data. If destination is on the same drive, it moves the data. Okay? It's a similar kind of psychology. It's a similar kind of behavior. Alright? Can't we just give the file name while creating the table? We did give the file name, right? What if this file, our file which we are trying to load, is existing somewhere else or is existing in the local folder, not in the HDFS? In those cases, you have to copy the file. Alright? Okay? Are you with me? Source file name from where you are loading the data. No, I do not get your question. Can we just give the file name while creating the table? We did give the file name while creating the table. If the data is not existing in that file name, then you will have to copy it from somewhere, correct? And then, okay, source file name from where are you loading the data? We tried to copy the data once from the local folder, second from the HDFS. So Manish's question is, Pig has execution engine on the machine it's running. How it's different for Hive? Correct. So in the same case, Hive also has an execution engine. In the similar way, Hive and Pig are very similar. The difference lies in the way both operate. For Pig, people need to learn new language. For Hive, people don't have to. Pig can handle unstructured data while Hive cannot. Pig has a built-in lot of optimization steps while Hive cannot because of SQL limitations. Alright, so those are the few things. Alright, okay, so here we are. Alright, now we were able to execute these kind of complex queries. Okay, we were able to even say uh, greater than this, less than this, and all of that. Right, now data we have shown you. So if you do not specify the table name, then by default it is going to store the data and or it is going to look up the data at this location. Okay, under apps, Hive, and warehouse. Okay. Also, the way we loaded the data from a table, we can also save the data from the table into a local file or into a HDFS folder. Okay, just opposite of load, this is what it is. So we can basically say that insert into local directory and we can specify this directory. In this case, whatever data is coming from here is going to be saved in this location. Okay, in the local folder. If you do not specify local, then whatever data is coming out of this is getting stored here in HDFS. So this is for exporting data from the table into file. Alright? Now, your data might be located into multiple files, or you might want to separate your data into multiple files. Okay, so say for example, data belonging to one particular criteria is in one file, data belonging to another criteria is in another file, and the format might be different for both the files, right? In those cases, we use partitions. Okay, so the benefit of partition is that it basically, when you are saying, when you are looking for a particular data, it will only look into those partitions where the data is located. For example, if we have specified that 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 for people in my class whose name start with S should their data should be in this particular file, while whose name start with A is then data is in this particular file, and so on. So these are called partitions. Now the benefit of this partitioning is when somebody is saying select star from people where name equals S, it will only look into one file rather than all files. And this way we can avoid the full file scans, and we just have the partial file scan. Okay, we'll not have to go through the whole file. Instead, we are just going through the one file. Okay. Also, the partitioning can be based on multiple columns, and the data is going to be stored based on various combinations of values of columns. Okay. So you have to define the partition using partition by in create table, and you can also add a partition later. So we can define the partition table like this. Okay. So you can see here we have one table called the amp. Okay, let's see what is there in the amp. So this is my folder, and there are these two files. One is the amp and the amp1. Okay, you can see that these are the records, and we are going to load these two set of data in our Hive with different set of columns. All right, so we create a table here. All right, what does it say? The employees table already exists. Drop table employees. Okay, so we have got this table. Select star from employees. There's nothing in this table right now. We have created an employees table which has three columns: name, salary, and degree. These are the three columns, and same thing is here in these both tables. Okay, now this is what we have in those tables. Now we are saying partition by, we are adding one more column called qualification. Okay, based on which we are creating the partitions. Okay, and row formatted as usual is, here comma separated. You can see that data is comma separated. And what we are trying to do is, now first let's load this data, and we are marking that all the data coming from the amp will have this value qualification equal to 1 as the partition. Okay, and the data coming from the amp1 is going to be in the partition called qualification equals 2. Okay, now if you do that, you have we have loaded the data successfully. So we have loaded now. We missed the bracket actually. All right, now let's have a look at the employees table now. So you can see that there is an extra column here, the fourth column, that is qualification. This is the partition column. Okay, now okay, so now if we basically try to do select star from employees where qualification equals 1, it will only query the first table, not the second table. Also, you can see that it did not execute our uh, map reduce. Why? because qualification equals to 1 gave us a partition, single partition, and to get the partition we have to just read the data rather than executing map or reduce. Make sense? The partition is clear to you? And under employee table in this, here we did not specify any location. So by default, our table is going to get created in warehouse. Yeah. So you can see that in warehouse we have employees table. Under employees table we have two folder, qualification equals to 1, qualification equals to 2. Under each folder is our file for that partition. Okay. The advantage of the advantage of partitioning is we will be able to, yeah, hello. So yeah, I know the voice is breaking. Just give me a second. I'm just trying to see what's going on. Yeah. So is it clear now? Is it okay? But the speed is really horrible. The speed is actually horrible. All right. All right. So yeah, I'm hoping the internet speed is okay now. Is my voice feebly audible to you? Is it breaking now? Alright, so let me take a step back and explain again. So we created an employees table and we define a partition column, okay? And we are saying put this file into first partition, put this file into this partition. And the name of the partition is qualification equals to 1, qualification equals to 2. Alright, so whenever we are querying employees table and we say qualification equals to 1, it is going to query only this file. Okay, because that falls into qualification equals to 1. Okay, under employees table, every partition is going to create this kind of a folder. Okay, so when we are saying select star from employees where qualification equals to 1, only this folder is going to be read. Okay, if we are saying select star from employees qualification equals to 2, only this folder is going to get read. Okay, so when we are creating partition, under the hood it is going to create multiple files for each partitions so that we don't have to read all the files in order to achieve the efficiency. Okay, so whenever we are querying the table, first it tries to find out what is what is this column type. Is it partitioned? If we are trying to look up the data that contains a partition, then first it will basically look only in that file that is part of the partitioning, and then it will apply the MapReduce on that file. So this way we can basically reduce our headache of scanning through multiple files. All right. Kalyan, are you okay now? All right. So just like any other database operation, we can alter table, rename it to something else. We can also change the column data type or the name, and we can add comments, and also we can add columns into this. Also, we can drop a partition. So similar to our usual table, we can put an external keyword, and we should be able to create the external table this way. The only difference is the external keyword. What difference does it make? If we are dropping this external table, the underlying data will not get deleted. The data will remain as such. So as a general strategy, try to create external table rather than internal table. Because the general mistake is that we have some HDFS file, we load it into our table, and then we deleted that table. Now what happened was our HDFS file was moved into this table, it was moved into this location, and the moment you drop the table, that file will get deleted. So there is a huge chances of data loss with the internal table. That's why you should generally use external table. If you are dealing with temporary data which you don't want later on, you can use the internal table, in which after deleting the table, data will also disappear. Okay, so whenever you are creating you are loading data from external source which you do not want to get deleted after table deletion, then use external, right? Okay. The other important part is you can also have an external table which is located somewhere else, such as on S3, Amazon S3. You can say that my table is this with these column partitioned by this, row format is separated by space, and lines are separated by /n, and location is on S3. Yeah, it actually moves into trash, but why do you want to be in that situation? Okay. All right. Also, the Excel table can also be partitioned such that each partition can be located on different locations in remote. Okay. For example, we have an external table called log messages, and part of the log messages is in HDFS. For this year, this month, and this particular day, the data was in HDFS. For this year, this month, this day, the data is in this location. okay, in S3. And so essentially we can create external partition table in order to basically have the data from various sources. Yeah. So means if we delete table, it is going to delete the raw file along. Correct. If we drop the table, then it's going to delete the underlying data. If it's an internal table, in case of external table, it doesn't delete the data. All right. Okay. So Anand's question is, what happens when we read data from external table? So when we read data from external table for our query, it actually downloads the data. There is a network transfer. All right. There is a network transfer that happens. Okay. Therefore, when you define the partitions properly, if you have 15 file, you have some folder structure remotely, you can define the partition properly so that only partial data gets downloaded rather than the full data. All right. It will not download while creating the file. It will download while we basically query the data, because while querying the data only, it will come to know that what section of data are you looking for. If you are just looking for one particular file, one particular partition, then why should it waste all the bandwidth to download the whole data? The purpose of an external table is that your data might be lying on external sources and you do not want to copy all of that onto your local one. Alright? No, if we are deleting an external partition, it is not going to delete the folder. So if your table is external, like here, so here we have create table employees. Okay, so we can say, what was the delete partition? Help delete. So delete partition employees qualification equals 1. So we just need to see what is the exact alter table employees employees. Okay, then we say drop if exist partition called qualification equals 1. Okay, now we say select star from employees. So only one partition is left. We have deleted one partition. And again let's go back to employees table. So now you can see that the actual data, the folder is also deleted. If the table is if the table which you are dealing with is an internal table or managed table, dropping a partition basically deletes the data. Okay, and if your table is external, then dropping a partition does not delete the data. Alright, that answers your question, Manish. If we drop external table, the data can't be accessed using table name, however, can be accessed in. Yes, that's correct, Kalyan. In the way you were usually accessing the data, you can continue to access the same data. Just that after deleting the data, that window to the file has been removed. You'll have to go directly to the file. Alright. So here are few notes what we have gone through so far. Each table has got a location. By default, table is a directory under this location if you do not specify. You can override the location by mentioning the location in the create table clause. Load data copies data if it is local. Okay. If the data is local, it copies the data. Load data moves the data if it is on HDFS for both external and managed table. Okay. Dropping managed table creates the data. Dropping the managed table deletes the data at that location, and dropping external table does not delete the location. Also, dropping a partition from managed table deletes the data, while dropping partition from external table does not delete the data. The metadata is stored on relational database called metastore, and here in our case it's MySQL. All right. Okay, so select statement, nothing complex about them. It's usual our usual SQL kind of select statement. All right. Also, you can have a very complex select statement like this. Here we are using a function called upper, and then we are here in this one we are accessing a map called deductions, and out of that map we are only trying to access the value of a field called federal taxes. Similarly, we can have a complex field where there is a function, there is a call to function, and we are passing this value to the function after multiplication and doing mathematical operations, and that too with a map. Okay, so we can have these kind of computations on the columns. Metastore can be other than MySQL. Yes, it can be. You can configure Metastore at Hive level. All right. So this is one. So there are standard aggregation functions are available like count star, average, sum, everything. And sometimes you can avoid the reduce phase for some of these aggregation functions. For example, count star. For count star, average, and sum, in both all the cases we can do it in the map size. If we are doing aggregation without a group by, we can get it done on the map side itself without the reduce side. All right. Okay. So we can create views. Okay. A view is a representation of your query. So when you have a very complex query, parts of the query you can convert into views. And if you are creating views on top of a big table, then basically every time you access a view, it's going to execute the query. Okay? So here we are saying we are giving a name to our query. This is the name called tweets underscore clean is the name to our query, this one. So every time we are going to say select star from tweets underscore clean, it is going to call this query. Okay, this makes our life very easy. This makes our SQL query uncomplicated. This uncomplicates our SQL query, and it makes easier to understand. It makes our queries more modular. So for example, you had big query. If you break it into logical views, so you can use views as part of other queries as well. You will see that we will extensively use views in when we are talking about the project. All right. Deductions is a map. Okay. Kalyan, deductions is a map here. You remember we were talking about a complex field, and there we talked about structs and maps. So deductions is a map. Alright, now we have got tweets underscore clean. So we can select star from tweets underscore clean and get the results. Alright. So basically we will see in one of the projects that we'll be using views extensively, and if you and views do not store the data, they only represent a query. Okay, so that every time you are querying the views, you are going to get the fresh data. Alright. Also, just like our pig, we can also create custom functions in Hive. Okay, we can create custom functions in Hive. The procedure remains exactly same. So we extend a particular UDF for each function we want to create, we extend UDF, and then we implement a method called evaluate, and there we'll be doing the actual work. All right? No, it doesn't support triggers. All right? Because yeah, it doesn't support triggers. All right? Now let's open Eclipse. So whatever function we create, it is going to whatever function we are going to create right now, we have to go through the same route, and then basically create the class, export the jar, upload the jar, and then okay, and then we will basically run it. So yeah, create the jar, and once you have uploaded the jar, then we can add jar into our uh, Hive and then run it. Okay, so here you can see, this. All right, so all we need to do is file, export, jar, and we specify our output folder here, hive udf.jar, and we can say finish, override. Now go to local. This is our local folder, cd downloads, and we can say scp and hive udf dot jar. This is what we had created, correct? We had created export jar hive udf dot jar, and we are going to copy it to student hadoop 1 dot no big data dot com colon into sgd folder. Okay, so I have just created a jar. Jar is a bundle of Java compiled code in which our definition of this custom function is there. So we are trying to customize or create a function called lower. You can see this lower. We are trying to create function called lower, which can do which can basically do whatever we want. The only thing is here, just to keep it little distinct, instead of lower we are actually converting into uppercase. Okay, it's basically a oxymoron, and we are trying to do that. All right. So we have already copied the data. Now next step here is, yeah. So we go into Hive. Let's say if it is there. So cd. So yes. So yes, it has been uploaded 23 May. Okay. Hive udf.jar. It has been uploaded properly. Next step is that we say here, okay, add jar, and we say asgiri slash hive udf. So it has successfully added this particular jar, meaning it has loaded our module, and now we can start using this function which we have just done. Also, we can first create a temporary function called this. Okay. We are creating a temporary function called mylower so that we don't have to refer it again and again. And once we have done that, we will use this. So we just created my underscore lower as an alias to sg.lower, and we are using that my underscore lower everywhere. Okay. So now you can see that it has converted into uppercase, and this is what our code was doing to uppercase. All right. You can see the detailed example on this URL. All right. So yeah, that was uh, custom. Yeah. Also, if you want to load JSON data, you can download the JSON Serde. Serde means serializer, deserializer, and you can download the binary from here. And once you have downloaded binary, you can add the binary just like the way we added, add jar, and then the name of the jar. And afterwards, you can start loading it. You can start specifying that as a row format. You can see that this particular class is coming from this jar. We are saying our row format Serde, meaning serializer deserializer, is this much this. So just like we specified input format earlier, we are specifying the row format here. Okay. And alright, this way it will convert our data as a, if our data is in JSON, it will convert that into a tabular format. So can you think of some good example where people are using UDF in real-time scenario where Hive is lacking? So there are not only lacking of the Hive, but also your custom business logic. Lot of time you want to run your custom business logic inside Hive. Okay, in those cases you also write Hive UDF. Along with that, there are many functions such as the complex functions such as comment out the special characters in HTML. Okay, or those kind of functions are not there in Hive. Okay, so yeah. So there are special text processing which are only possible, like for example, we discussed earlier about converting an integer into hexadecimal number, right? Or say we have this, what do you call? I forgot the. So you have uh, ampersand, and ampersand need to be converted into ampersand this kind of values. These are HTML commenting the HTML kind of commenting, right? In those kind of thing, yeah, not Unicode, but all right. So there are many use cases. You can go through the list of Hive functions available, and then you can decide by yourself. All right. And okay, is one time job add jar command? You have to do it every time. Thank you, very good point. So you have to do it every time you run your SQL query. Okay, so this will become part of your SQL script. Okay, now commit or rollback are supported in Hive or not? No, because it does not let you that edit the data anyway. Okay, commit and rollback supports are not there right now. All right. Yeah, no update or insert. Correct. All right. So let's take a break for 10 minutes. All right. All right, so let's start. Are you back? Should we start now? Great, great. All right, so we discussed about how to load the data and external surveys, serializer, deserializers, and you can have more detailed example on how to even create your own serializer, deserializer. All right, so here we are. Now the issue comes with respect to order by. So order by, though it sounds like straightforward and works fine, the problem with order by is that order by has only one single reducer, meaning no matter how big is your data, the ordering will go through only a single reducer. Okay, that causes a lot of problems. So is it possible to write insert updates in UDF? No. So what do we do in UDF? First, what we do in UDF is we are able to write functions which we can which we can call on values of columns. In UDF, what else we could write? We could write serializer, deserializer. What does it mean? Serializer loads the whole file, means converts. Sorry, serializer takes a table, database table, or Hive table, and converts it into an HDFS file, that is serializer. Deserializer takes the input file and converts into rows and columns in Hive, that is deserializer. Okay. I- Other than that, you cannot do things like insert updates using UDF. All right. All right. So everything was fine till the point of order by. So order by was basically the way it was designed was it was running only on the single map reducer. Now the moment we try to okay try to use another syntax called sort by, okay, it basically gives adds more reducers. So using sort by, we can specify number of reducers. Okay. Now reducers, when we are sorting using ordering by using multiple reducers, what will happen is the result of each reducer will be sorted. But result of each reducer will be sorted, but overall results will not be sorted. If you remember our word count example with two reducers, both files were individually sorted, but when we try to connect them, concatenate them, the result was not sorted, right? So that's the same scenario with sort by. Okay. Now before that, after that, what people did was they included one more syntax called distribute by. Distribute by X is similar to saying partition by. Okay, if you remember partitioner, so it's saying like first partition my data into these buckets, okay, and then pass it through the sort by, and then we'll get the results. Okay, so so basically, after a lot of hit and trials, it was decided that distribute by and sort by combined together will give the correct results, and hence a separate syntax called cluster by was created. Cluster by basically sorts the data properly using multiple reducers. All right. Okay. cluster by a particular column basically first partitions the data into multiple reducer, then sorts the data using multiple reducer, and then concatenates it back. So order by X, order by one column, if your data is really huge, you should use cluster by rather than order by. Okay, you should use cluster by rather than order by, because order by uses only single reducer while cluster by uses multiple reducers. Okay, so let me little demonstrate to you a little bit. So let's say in our word count example we had apple, apricot, bird, and bat, right? These were the input data. Now if we had two reducers, correct? So what will it have in two reducer? Part 1, part 000 will have apple and bird, while part 0001 will have apricot and bat, right? This part 001. Now, if you have two reducer, now you can see individually the data is ordered. Do you see? Individually the data is ordered. But if you concatenate part 1, part 0 and part 1, the result might become awkward. If you say concatenate these two results out of, so yeah, like this. So the result is not ordered. You see that? So that is why the moment we said distribute by X, it basically ensured that each of, not distribute by, sort by, when we said sort by, it basically created multiple reducers. Each reducers can receive overlapping ranges of data, and you end up with n or more sorted files with overlapping ranges. So that was the problem. Okay, overlapping ranges as in from A to B is also in the first one, and A to B is also in the second one. Do you see that? So that was exactly what sort by was doing, although it was using multiple reducers. Now the trick was, while creating the multiple reducers, the way we separate the data was apple and apricot goes into one, while bird and bat goes into second one, right? So, and that's something which was done by distribute by. It's like defining a partitioner. If you remember the way we defined our partitioner, we said if our value is lying is less than equal to j, then send it to the first partition. If greater than equal to j, send it to second partition. That way, we manually segregated the ranges of the values such that if individual got sorted, we can simply concatenate them together to generate an ordered result. Alright, so that's something distribute by X did. What does distribute by X do again? Given the whole list of values, it broke down those values into multiple buckets so that those individual buckets get sorted by each reducer, and then we can basically get overall result get sorted. Okay, distribute by X made sure that the whole range of values which we are trying to sort get divided into mutually exclusive ranges. Okay, so say we say split the age of people into 10 buckets. Okay, so first bucket might contain 1 to 10, second bucket might contain 11 to 20, and so on. And once you sort this data individual buckets, and you just simply have to concatenate them to get the overall result. So that is something done by distribute by X. So sort by X and distribute by X, if you combine them together, That's what is known as cluster by. So in very simple words, if your data is huge, do not use order by, because order by is going to hit really bad on your order by is going to really hit bad on your reducers. Therefore, use cluster by, okay, if you have some big data, because cluster by is equal to distribute by x and sort by x. Okay. Similarly, while doing cluster by, you could define that you need these many clusters, meaning you need these many reducers in parallel, so that those many reducers can be created and done. All right. Okay, so we can we have already demonstrated this, but I would leave it to you actually. You should try this. You should create a table. This is a movie lens data. We will use this data in our recommendation example. Okay, where when we are generating recommendation, we will use this data. And for that, first you try to create a table and then download this data from the website. It's already downloaded into the folder, common folder, and you can unzip it. And once you have unzipped it, you will have this data located. Go through this data and then load this data into our normal table. Note that this data is separated by tab. And then you can start querying the data. This, what kind of data is it? It's a history of what people, which people liked what movie. Okay, it's a ratings of given by various people to various movies. Okay, so go through this and you'll get enough of you know try to execute this. Okay, I have already created my table. Select star from u underscore data. You can see that. So this is what you should get at the end of it. So take it as assignment, try to do it, and also once you have done that, try to do these two assignments. For each movie, how many users voted for it? Okay. For movies having more than 30 ratings, what is the average rating? Okay. For each movie having more than 30 ratings, what is the average movie rating? Okay. Try to do these two assignments. It is going to be a little difficult, and it's available in the my courses, so you can go there and write your answers. Okay, but before that you will have to load the data like this, and then only you can do. All right. So is this clear what needs to be done? I hope this is clear. All you need to do is create your table, but before that create your own database. Okay, create your database, create your table, and then download the data and unzip it, and then load the data into the table, and then you should write the queries. First you try to write a simple query like this, and then you write these two queries. All right. Once you are done, please share it with me. All right. All right. So that is pretty much what we had to talk about our Hive. All right. Any questions here before we move forward? Yes. So Manish's question point is, so distribute by is equal to distribute data in partition but no sorting. That is correct. It's like writing the partitioner. Cluster by means creating partition with the sorting. Yes. So cluster by when we say it includes distribute by. All right. Good. Good. Any other questions? Yeah, no questions? All right, all right. So should we proceed further? All right. So today we are going to discuss and we are going to start something called NoSQL. All right. All right. So the main purpose of NoSQL is that in case you don't know anything about SQL, you can confidently say that you are expert at NoSQL. All right. So yeah. All right. So before we start with NoSQL, let me try to explain to you what does it mean by scaling out and scaling up. Yeah. So, all right. So here you can see that this person is having a bullock cart. I think it's a horse cart. Horse cart with a single horse. Now, the moment he realizes that this is not sufficient to carry the load, and he has two choices. One, sell the horse, buy an elephant, change the cart, and carry more load. Other is add more horses into the cart. Okay. So adding more horses into the cart is called horizontal scaling and scaling out, while adding while taking up an elephant instead of a horse is scaling up. So interestingly, scaling up has been the order of the day for most of the tech industry for quite some time now. We have been obsessed by buying the dual core, core to duo, and the basically we have been obsessed with assuming that buying an elephant will suddenly solve our problems. Okay, so but in the real scenario, it's not this vertical scaling that solves your problem. It's the horizontal scaling. As in the discussion on the first day discussion also, it takes a little bit of time to realize that it's not the only processor which matters. It is also when we are horizontally scaling or when we are trying to scale up. So when we hit a limitation on a single computer, it's not only the processor, it's also the RAM. It's also the bigger problem as of today is reading of the data. The speed at which we read the data is humongously slow, and that's what slows everybody's down. Similarly, the other bottlenecks are the 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 data bus connecting the RAM and the processor are fairly slow. I mean, slow as compared to the RAM speed or the processor speed. So, no matter what you do, no matter how much you increase the processor, the overall speed is going to be slow. Alright? Though, okay, So though lots of people beg to differ here, but but it has been proven in past 5 years that the systems are not scaling up. Okay. Now you can say that here. Let me ask you this. So although elephant sounds like a brilliant idea, but how many horsepower does an elephant have? Can anybody tell me? How many horsepower on an average and does an elephant have? Just rough idea. Okay. So the interesting part in this analogy is that elephant is hardly 2 horsepower. Okay. Elephant is hardly 2 horsepower. Okay. Sounds like it might be having at least 5 horsepower or 10, but interestingly, when if you search on the net, you will find that it's hardly 2 horsepower. Okay. So anyway, coming back to the analogy, while on the other hand, you can if you do the horizontal scaling, you can add more and more horses and have more resilience. Meaning, if tomorrow you don't need to carry that much data, sorry, that much load, you can basically remove few horses and still be happy, right? So this analogy stands true for a lot of other use cases. So basically, that was the definition of scaling out or scaling up, horizontal scaling or vertical scaling. All right. Now the question is, why do we need NoSQL? NoSQLs are a new kind of databases, and why do we need NoSQL in first place? The answer is very simple. It's not about programming model, this, that. That is just a stupid argument. What is most important in understanding NoSQL, the whole NoSQL or these new kind of databases have been designed bottom up. First, for handling or storing big data. Second, giving brilliant availability, meaning if few machines are down, still the system keeps running and the the users do not go unattended. All right. Then is third point is the scale out architecture. What does it mean? Okay. Today you have 1 terabyte of load. Tomorrow you might have 150 100 terabyte of load, and a day after you might have 1 petabyte data. So you should not be changing your data strategy as the data grows. Your database should be able to scale up. Okay. So That's what is called scale out architecture. Meaning, today you have two machines running. Tomorrow we can keep on adding more and more machines without having to do any program change, any software upgradation, or without having to modify our web application. Okay, so that is called the scale out architecture. So these are the main three reasons. First, big data. Second, high availability. Third is scale out architecture. Today you are serving to 1 million users. Tomorrow you might be serving to 10 million users and so on. So all you have to do in these cases is add more and more machines and you should be able to handle it. These are the three basic things for which we need NoSQL databases. Okay, so what is NoSQL database? So a NoSQL database is basically for distributed architecture. We have already discussed about distributed architecture where we are making multiple computers talk in conjunction. Okay, that is distributed architecture. We are using multitude of computers or many computers to solve our problem. Okay, so that is distributed architecture. Now, by virtue of distributed architecture, there are multiple things which are common in all NoSQL databases. First is there is an identifier for the record. As you can imagine, you can vaguely imagine that you have a big database table and you want to store it in a network, right? So you might have to store it like first few records somewhere, other few records somewhere else, and so on. Now, you have distributed these records, right? Now to have them to be able to serve these records, you should be able to identify these records, and therefore for all kinds of NoSQL databases, a common thing you will find in all of those is there is an identifier for record. There is a unique identifier for each record. Be it MongoDB, be it Cassandra, be it HBase, be it CouchDB, be it anything, they have to have an identifier. Okay, identifier can be exclusively identifier, or it could be something like a key value pair where key is distinct. Okay, the although NoSQL was was by coincident, it was just incidental name, but people have found the meaning of it, not only SQL, new SQL, and whatnot. Okay, it's non-relational, meaning they could not. We will show you that if we try to implement, if we try to provide the relational properties, meaning a strong relation between the record, foreign key, primary key, and all of that, then the whole purpose of distributedness gets defeated. Okay, therefore none of the NoSQLs are able to implement relational databases. Then is open source, because so when you are building a database, so when I was building tbits in 2006, so after a few years of development, we realized that the only reason we could not scale up was because people were not open to use our database. Okay, people are not open to use our system. Why? Because our system was closed source, so we tried to make it open source, and if we had made it open source, we could have become really really popular. Because when somebody is putting data into your database, right, then they have this innate fear that what if tomorrow your company shuts down, right? Therefore, anybody in the world, if they are building a product which stores their data on their premise, or something like a programmable thing, they have to make it open source. Otherwise, no organization, no small or big organization is going to adopt. Specifically, no developer like ourselves will ever adopt a database where there is a fear of getting logged in. The vendor lock-in, they call it. So therefore, it was made open source. Okay, so that there is no vendor lock-in, there is no fear of a company shutting down. Okay, so therefore, anybody who creates a new database generally as of today comes up as no open source, and NoSQL databases are on the same line. So almost every NoSQL is open source. Horizontal scalable, again, we have already discussed this. Schema free. So schema free as in lots of people realize that I'll show you a case study also, that providing a schema restrictions like usual relational databases is actually a very big setback. Okay, is actually a very big setback. Easy replication as in data keeps on getting replicated easily, meaning that we don't have, because when you have this kind of humongous data and data is spread across the cluster, you have to provide the backup mechanism, just like our HDFS did a brilliant replication. Similar thing is provided by all NoSQLs. simple API. Now, not every database is able to provide a relational kind of query language, SQL query language. Therefore, most of these databases try to be very, very rudimentary. And to be honest with you, 90%, more than 90% of the all NoSQL databases, maybe 95%, almost all of the 90 NoSQL databases are not qualified enough to be called a database. Most of these are data store because not even, hardly few provide a full-fledged SQL kind of language for data in and data out. So most of them provides a very simple rudimentary like key value pair, get set kind of get put methods. They those kind of things they provide. So that makes them a simple API thing. So that the API does not become the bottleneck. All of them are meant to manage huge data on commodity hardware. So commodity hardware is something important. Now when you have scalability, really, really brilliant scalability in place, you realize that you don't really require blade servers, very expensive servers. You can be happy with a small amount of small servers. Small servers means $1,000 minimum. Okay, I mean the commodity hardware does not mean the broken hardware or hardware which has bad components. Okay, it only means that a usual server. It does not mean most of these databases when they run in the data centers they cost really humongous. Okay, that's something you don't require because if you know about Google guys, what they did was when they were building this crawler, all they did was they went around the college, bought everybody's old computer, and started using that. All right? Yes. So cheap hardware does not mean that the components are cheap. It's just less costly. Replication is like HDFS, where we had one block copied onto multiple machines. Okay. So similarly, almost all NoSQL databases provide a mechanism to have the duplicate data, copy the data across the cluster, so that every node can be a redundant node. All right. Okay, so there are four major types of NoSQL databases. First one is column-oriented database, or we call them wide column. Second one is document-oriented database. We call them, there are databases such as MongoDB, which are document-oriented. In case of wide column or column-oriented database, they look very much like your database table. Okay, we will talk about what is column oriented in a few minutes. So, a document oriented database is something like you can see on the right hand side. TV shows have seasons, seasons have episodes, and episodes have reviews and cast members. So you can see that it's a complex structure, one inside another. It's not flat like your relational database. So if you have your data in that form, you can use document oriented database such as MongoDB, CouchDB. Okay. Now, if you want to use a key value pair kind of databases, key value pair kind of databases are probably the first generation of NoSQL databases. The first of them was Dynamo from Amazon. So first NoSQL was Dynamo from Amazon, where we kept on, where they basically gave you a key value count of storage. You store the value in and the key together into the Amazon database, into the Dynamo. Okay. Now there are multiple kinds of key value pairs. There is Redis, there is Voldemort, MemCacheDB. although memcachdb is not really qualified enough to be called database, most of these are very rudimentary and with respect to the API, they are very rudimentary and very primitive. Okay, memcachdb is more like a data store, get and put. All right. The fourth one is graph databases. There is a new generation of databases called graph databases. When you deal with finding roots in a map or finding the common friends between two different persons, now or finding a route, meaning how am I connected to Tarak, for example. So if we have to find that kind of thing and we have to find that kind of relationships between people, then we use a graph database. A graph database is basically a complex way of representing graph, and it makes it possible to give you the basic algorithms on graph, and it also lets you traverse the graph very quickly. So algorithm like PageRank is implemented in almost all the graph databases, and few of the popular ones are Giraffe and GraphX and Neo4j. Okay, so a summary of NoSQL versus SQL you can go through. Okay, and yeah, you can go through that. Now, there is one thing very important I want to discuss, something called CAP theorem. CAP theorem says that out of three systems, three things, you cannot have all three. So, just now, just a minute ago, we told that NoSQLs were not able to provide relational properties, or NoSQLs were not also able to provide ACID properties. Okay, so therefore, most of them have had a different consistency model. Okay, so for example, MongoDB is not able to provide the ACID properties like atomicity. Who can help me with ACID properties of the database? What is ACID properties of a database or a transaction? Atomicity, consistency, then isolation, perfect, durability, perfect. Okay, so all NoSQL databases are all relational databases, be it MySQL, Microsoft SQL, Oracle, all of them are able to provide you brilliant transaction, brilliant consistency. Atomicity means either the whole data gets written or it does not get written. There is no midway. It should not be that half of the cell value got written while while the data got corrupted. Okay, so atomicity is that. Second is after atomicity comes your similarly atomicity on databases is based on row, meaning we should be able to store a full row into the database without the middle state being visible to people, meaning three rows, three columns out of a row got written and the other user is seeing the half written data. So those kind of things are well done in case of relational databases, but those kind of properties, the ACID properties, are not provided by any of the NoSQL databases, and there is a very good reason why. The reason is, if you try to provide those properties, then the availability is lost. The high availability is lost. Okay, and why is it so? So it is given by CAP theorem. CAP theorem says that out of three things, consistency, availability, and partition tolerance, okay, it is impossible to get all three. You can at most get two out of it. Okay, so what does it mean by consistency? First is all the nodes see the same data at the same time. If I've just written some data, I'm reading it back, I should get exactly what I just wrote. Okay, that is consistency. Availability means that Availability means that no request goes unanswered. Okay, even if either success or failed, those kind of response should go. The more requests you are able to handle, the more available your system is. Okay, now, and partition tolerance means that even if your machines are shutting down, how much party how much how many machines can be shut down in your no in your cluster, still keep it running. Okay, that is called partition tolerance. Even if your network get partitioned by disconnection, still your data should not get lost, your users should not go unanswered. So that is called partition tolerance. The more tolerance can you give, the best is your partition tolerance. The more, basically, the more nodes shutdown you can tolerate is the the more partition tolerant you are. Okay, so that's called partition tolerance. Now, cap theorem says that out of CAP, consistency, availability, and partition tolerance, you cannot have all three. Either you'll have to get either you will have to sacrifice consistency or availability or partition tolerance. You can, or more than one of those. Okay, you cannot have all three. So in this diagram on the right hand side, you can see the database called Big Table from Google and HBase and MongoDB. They lie in consistency and partition one, but they are not highly available. Okay, so I'll show you. Now, this diagram states the reasoning behind cap theorem. Let's imagine there are three architectures possible. The first one is a single computer. This is how we had been doing databases traditionally. We had a single computer, we were happily using it. All the users were writing to the single computer and reading from it. Okay? Now, if this machine goes down, nobody will be able to use this. Right? All the users will go empty handed, and therefore it is not available, and it is also not partition tolerant. Why? If this machine goes down, then all users go empty handed. That is called partition intolerant. It's not able to tolerate the partitioning. It's not available because if one user is reading at the same time at a time, the other user will have to wait for a long time. The more the number of users come, the more the wait will become. Okay, and and the weight will become higher and higher as the numbers are as the more users are coming. Also, every node or every single computer has limitations on how many sockets it can open. Therefore, the first configuration is not really partition tolerant, not really available, but it is strongly consistent. It's strongly consistent. Whatever a user has written, the anybody else who is coming just after him will get the recently updated data. Cap theorem says that. Okay. Now the second configuration is you have two machines A and B. All the writers are going to A, all the readers are reading from B. Now, this kind of structure gives us the ability to read from multiple machines. That means it has got availability, high availability. We can add more and more machines similar to B from which we can keep on reading. Although the writing will be still the bottleneck, but reading will be really, really fast. And therefore, such kind of a system is fairly available, meaning lots of machines are available to read the data, and there is a separate machine, dedicated machine for writing the data. Therefore, it is highly available. Similarly, if A goes down, we can start writing to B, and still the system will be available. Or if B goes down, we can start reading directly from A, and hence this system is more available than the first configuration, right? But the system is not consistent. Why? Because imagine that you have just written some data to A and you immediately start reading that data. For reading, you go to B. For writing, you are going to A. And therefore, the data which you will retrieve from B, which will be that will be stale. It will take some time for data to get transferred from A to B, right? And therefore, you will when you start reading immediately from B, you will say that this row is inconsistent. I wrote something else and I'm getting something else. I'm getting an older data, right? And therefore, the second configuration is not consistent, but it is eventually consistent, meaning eventually B is going to be in peace. Okay, B is going to get updated after some time or eventually. So this is not consistent but eventual consistent. So most of the systems actually settle down for eventual consistency in case of NoSQL domain. And eventual consistent, one of the examples is MongoDB. And other example, so most of the databases actually are eventually consistent. Now third configuration, like our name node and secondary name node kind of a model, you can see that there is a machine which is getting replicated onto B. And just give me 2 more minutes, and I don't want to break the flow. So we have got A machine and B machines. All the users are reading writing from A, and that data is being copied onto B, just like our name node. On name node, all the users were writing the data to the name node, and it was backing it up onto the backup name node. Correct? Now, in this model is fault tolerant, as in if A goes down, we can immediately replace A with B. And the data is also consistent in the sense that all the users are reading writing to same machine. But this architecture is not really available. Why? Because all the users are reading and writing from the machine A, and effectively A is the bottleneck, right? There is a limitation on how many. So all the readers will be waiting while writers are writing the data, and therefore this model is not really tolerant. This model is not really it's partition tolerant, but this is not highly available. Okay, so this diagram is my own, and this is the best way I could explain cap theorem. And if you can come up with another architecture, I would really appreciate. Okay, so these are the three. Most of the architectures can be broken down into these three models. Okay, this is actually very oversimplification of cap theorem, and this is possibly the best way to understand the reasoning behind cap theorem. So as you can see in these three diagrams, none of the architectures are really giving us all three CAP. Okay, first one, our traditional RDBMS, was only consistent, not available, not partition tolerant. While second one is not consistent while available and partition tolerant. Third one is not available but partition tolerant and consistent. So this is cap theorem. All right. So does it make sense to you? All right. Let's see. Let's discuss tomorrow, and we will go into one case study tomorrow, not on next Saturday. In the meantime, please finish your all assignments, and if you have any questions, let me know. All right. Okay, then have a great. Oh, it's only 9:35. I'm sorry. We still have 30 minutes. I'm extremely sorry. Okay, so I had given the session yesterday night, so there the session goes till 11:30, and that's why I was thinking that time is up. Okay, are you guys with me? All right. So cap theorem is clear to everyone? These three diagrams? Great, great. No questions right now? All right. Moving ahead, so let's go through a traditional RDBMS story. Okay. The traditional RDBMS story is, I mean, I'm telling about these typical companies which actually shut down in 2000s because they couldn't handle the load and the designs were pretty bad. And I know a few more friends who actually got shut down because of these reasons. All right. So typical RDBMS story is that today you are launching a website and you move your code from local workstation to the server, and bingo, there is your machine running and you have champagne bottles and the service is launched. You get covered in the news, service becomes little more popular, too many reads are hitting your database. So what you do is you so your service is becoming popular. Okay. So yeah, this will give you an idea, Manish. Just go with the flow right now. Okay. Definitely, this is going to give you. So so you have a public launch. You launched really beautiful website recently, and you got covered in news. Service became popular. Lots of people start reading from your server, and you realize that it's getting really slow. So all you do is you add the caching. Caching, general solution for caching was and is memcached. Memcached is a daemon which runs in the network and caches your most frequent responses you can store in the memcached. Now, the moment you bring in the cache, the moment you start caching the results, meaning that you are not going till the database for querying, correct? And to refresh a cache, it is going to be take some time, correct? When there is a refresh of cache, somebody is trying to update the data, and then the you're refreshing the cache. So similar to our second model in the previous diagram, where the data getting reaching from A point to B, the changes makes it inconsistent. Meaning there'll be a time where your data in cache is stale, and therefore your data has started becoming inconsistent. You have introduced inconsistency the moment you have bring in the cache. All right. So effectively, if you look at it from our DBA perspective, DBA will cry saying that our data is no longer consistent. Now, never mind. So it's not such a big deal. We have put a cache. There is one milliseconds difference in the actual data and the cache being refreshed. Service starts growing in popularity. Okay. Now, as the service starts growing in popularity, more and more people are trying to write onto your server. While reads you have solved, now writes are hitting the database. So, as the usual IT admin, what you do is, or a usual CIO, what you do is you scale your database vertically. Meaning, you just buy the costliest machine available, like having 16 cores and 128 GB RAM and fastest hard drives, and you say that this will solve all my problems. So it does solve your problem for few more days. Okay. Now, after a few more days, you hire, as you realize that, oh, I have solved the problem and we can now do anything we want. You hire these product managers and you keep on adding more and more features. And if you think about a website, the more features you add, you generally add more tables, and hence when the user is requesting for your website, when your user is requesting for your website, you join all these tables and cater to the users. And the moment when more and more features are adding, more and more tables are adding, and hence your queries will keep on getting slower because there are too many joins happening. And then you realize that why don't I just why don't I just denormalize the data? Meaning, why don't I create a single table out of multiple tables so that I don't have to join again and again. Okay. Now, the moment you say that I'm going to denormalize, DBA will get really furious and say that this is something which I have not studied. Okay. This is not what I was taught. I was taught to normalize the data, right? If you remember the chords principles, normalization and all that, right? Now, as the database, again, the database is still rising in popularity, but things are slow, okay? Things are slow, and so you try to do a couple of things. You stop using triggers. Triggers are server-side computations. Similarly, you stop using a lot of stored procedures. You delegate most of the computations to either your web server or to your client side in the JavaScript. So you try to delegate most of the server-side computation. So if you see that you are one by one stopping to use the features provided by the database. Okay, now you have even stopped using the triggers and stored procedures. After some time, some queries will still be slow. In those cases, what will you do is you pre-materialize, meaning pre-compute the results and put it in the data. Okay, you pre-compute the results of those queries, and and so that you don't have to do these computation. And if you look at pre-computation, what exactly it is like pre-caching, pre-preparing the data, predicting the future, and hence this is going to be inconsistent. You prepared the pre-materialize the queries. Now after some time the data changes, you again rematerialize, as in recompute the data, correct? And therefore also you stop joining. In most of the cases you start basically combining multiple tables into single so that I don't have to join again and again. Now your reads might become okay for some time, but writes will keep on getting slower, and you will stop. Why writes are getting slower? Because as you are increasing the features, you would be creating more and more indexes on the table. Okay, therefore you will stop using indexes also. And these are the real case studies, and I have seen this happening. Okay, we keep on dropping the secondary indexes and triggers. Now, if you see, if you see what all we dropped in on the way. First, we let go of consistency. Then we let go of the relational structure. Then we let go of triggers, indexes. We also let go of server-side computation such as stored procedures, and we also let go of our normalization, and we also combine multiple tables into single. So the whole purpose, the whole reason you created this grand database, you are using it as data in and data out. So exactly this is the reason why NoSQL was invented, for data in and data out. Okay, without any other features. So effectively, as the load grows, your database devolves. Okay, database turns into a simple data in and data out rather than a proper database. So that is the truth, and that happens when the load grows. Okay, and therefore it made sense to go for NoSQL databases when it comes to handling heavy load. All right. Okay, so before we get into our H-based discussion, I would like to explain to you what is column-oriented database. It's very important to understand that part. What is column-oriented database? A column-oriented database is where the data is stored, column-wise first, and then the then the data is first stored, first column is stored first, second column is stored afterwards, and third column afterwards. Okay, row oriented one, we store the rows first and then we store row wise. First we store one row, then another row, then another row. Now you might ask that, so presentation wise, from the user perspective, it both the tables look same, whether row oriented or column oriented, both the things are same. All right, both the things are same from the user perspective, but under the hood, the way the data is stored onto the file system, okay, there is the difference between the column oriented and row oriented. In column oriented databases, you store the values like, first you will store 10, 12, 11, then Joe, Mary, Kathy. Alright? This is column oriented storage. You can see that. In row oriented databases, you store 10 Joe, 12 Mary, 11 Kathy. So that is row oriented database store. Now you would ask, this is a very important question, some of you must have asked me in the past. So why do we need a column oriented database, by the way? Okay. Now you can see clearly that here in first column the values are similar. In the second column the values are similar. Meaning, if you have to do the compactness, if you have to do the compression, it will be better if we compress all the columns together, right? So few of the researchers, some people found out that if we compact, if we try to compress data column wise, then the resulting output is really good. Okay, for example, had this column been, so employee ID is there, right? So this whole values will be something between one value and the another, and hence, how should I explain this? So when the data is similar in nature, compressing the data is easier. Okay, you can always say this value has been repeated 15 times, this value has repeated 30 times, and hence the compression of the data is far better. Although it's fairly mathematical to explain that, why does it matter? I mean, if I have to explain to you mathematically, it'll be fairly complex. But I'm trying to explain in a very simple words that if you have data of a similar nature, it is generally the compression results are far better, and therefore storing column wise leads to a better compression than row wise. Okay, so that's the main reason why column oriented databases are more popular. All right, now some of the databases were very clever. They said that we don't know what user likes. We will take a middle path. Okay. In some problems, they said that for some problem, a row-oriented database is better. For some problem, column-oriented database is better. In those cases, what they did was they created something called column family oriented database. Each column family is stored first, then the next column family. Okay. A column family oriented database, the data in one column family gets stored first, then the next column family, and then the next column family. So which means data of a column family is closer to each other. Okay. So as you can see here, so there are two column families, CF1 and CF2. CF1 contains two columns, employee ID and name, while CF2 has age. Okay, in CF1, employee ID and name, this is the column family. Now the way the data gets stored in each column family is row wise, meaning 10 Joe, 12 Mary, 11 Kathy, and here it will be 23, 33, 45. So each column family behaves like our traditional table, and this big table contains multiple column families. Alright, so this way, if you have one column per family, then the database behaves like a column oriented database. If you have only one column family, then the table behaves like a row oriented database. Are you with me? All right. So a column family is a group of columns. Okay. And column family oriented database, the data in a column family gets saved first and then the next column family gets stored. Okay. So CF1, the data of CF1 will get stored first in a row oriented manner, meaning 10 Joe, 12 Mary, 11 Kathy. You can see 10 Joe, 12 Mary, 11 Kathy. While data in CF2 will be stored after this has saved, which means after we have finished writing 11 Kathy, then we'll write 23, 33, 45. Okay? So this is how the data gets stored in case of column family oriented database. Now, as you can see, if we make one column per column family, that means if we imagine that under CF1 is our employee ID. So we'll store this first, then next column family and the next column family. Correct? Therefore, if we have one column per family, that means the whole table will become column oriented. Now, if we have multiple columns in a column family, that means the if you have multiple columns in a column family, or if we have only a single column family in a table, that means that the whole table is row oriented. The way it is, the data is going to get stored. Imagine that there was no second column. There was no second column. Imagine that there is only one in the whole table. There is only one column family. That means the data is getting stored row wise, right? Therefore, column family is really clever way of representing data and probably the best out of all. I personally like it. And reason is that you, based on your requirement, you can basically turn it into either column oriented or row oriented database. All right, is that clear, Srinivas? Alright, now let's talk about HBase. HBase is consistent and partition tolerant while not very highly available database, and it is a column family oriented database. It is based on a paper called by Google, and the paper title was Big Table, and Big Table is what they use for storing the whole world's data. Okay, so and good news for all the HBase developers is the API of HBase, whatever open source world has created, Google is using the same API for storing the data on their compute engine. So if you are using internally HBase today, tomorrow your organization chooses to move to Google Big Table, your code will remain as such. Alright, so that's a good news. Now, HBase is great when you have to store billions of rows and millions of columns. It is strongly consistent, okay, not eventually consistent. Automatic sharding, as in if you have a big table, it will automate. And what does it mean by sharding? Sharding means sharding means the the table whatever you have gets sliced into pieces and distributed. That is called sharding. Sharding means cutting a big table into pieces and distributing it. So here there is an automatic sharding. We don't have to cut the table ourselves. That when the table is cut and distributed into something called a region server. Okay, region server, and there is a strong Hadoop and HDFS integration in HBase, and it provides you a brilliant computation using massively parallel computing using MapReduce. and it provides you a rudimentary API, very simple API, very trivial API to get and put the data into the table. And that API is available in Thrift. Okay, as we have told during our Hive discussion, that there is something called thrift that makes our life easier for service creating services. HBase also has thrift services, which means using every programming language you can access HBase. Also, there are HBase drivers which make it possible to connect using JDBC drivers to HBase. Okay. Similarly, we have coprocessors. Coprocessors make it possible to run the code on the server side. Coprocessors are very much like triggers in normal database. Then to make it efficient, to make the search efficient in the HBase database, you have Bloom filters. We'll discuss all of these. And we'll skip this. This is just we have already covered it. Now this is the general architecture of HBase. This is the general architecture of HBase. At the bottom of the game is HDFS and Zookeeper. At the bottom of the game is HDFS and Zookeeper. Now, just above HDFS, we have the whole HBase there. So HBase has got something called HBase master, and then there are multiple region servers. Okay, HBase master, as you must have guessed it, is for storing the metadata, while the region servers store the actual tables of the data. All right. Now, HBase provides you the API. This API makes the call to HBase master and the region servers to get the result. All right. So this is the general diagram. Now, with respect to the data model is something really important because other things are easier to understand. The most emphasis I would like to place is on the data model. Why? Because before developing an application, you have to understand how are you going to translate that into HBase. A data model is somebody who is doing the data model, he knows the problem statement, he knows what are the difficulties and where is the data going to increase. Okay, and the data modeler also knows that the strength and the weakness of the database on the hand, and then he connects these two points together to give you a really data good model to to basically represent your requirement. Okay, so let's understand first what does HBase provide you, and then once you know that what does HBase provide you, given a problem at hand, you will be able to translate it. Okay, so first of all, the best definition I have got of HBase is from the paper of Bigtable, and the definition is it's a sorted map. Map means map has a key and the values. Okay, value can be a complex value and key can also be a complex value. Sorted means the way the values are stored in the hash map are sorted. If you get hold of a key, you can go to the next key and that will be the next one. Okay, in the order. So if you have used sorted hash map earlier, you will get the idea. So it's like a two column. You can think of a key value kind of store where keys are it's sorted by key. Okay. Now the important part, the values are complex. Values contains the multiple fields, but you can store sparse things. So you can now take a step back and think of it this way, that you have got a big Excel sheet. Okay. Should we continue this discussion on the next? Because it's already 10 and it will take me a decent amount of time to explain the data model. Alright. So have a great day and please finish the assignment again. And thank you very much. Alright. Thank you, Srinivas. I'm happy that you liked the session. Thank you, Kalyan. All right. So, yeah, our next session, our next course is starting on 30 May. You can refer to your friends. Okay. All right. Thank you very much. Bye bye.